Okay, so what we're going to do now is we are going to determine flow using the Dupuit equation. And so up until now we've looked at completely confined flow. That's where our water table was above the top of the confining layer. This is a different case. In this case we will have water right here, and it's going to be unconfined. And so we'll call this value over here, this is going to be our H1, and then over here this is going to be our H2. And this is going to be an unconfined aquifer, and so the water flow coming through here is just going to be from these two values. And what happens is it is a variable as you come through the ground, and so we can't assume that it's a constant value, so the derivation is slightly different. So here the flow is negative K I A, and remember this is Darcy's law. Okay, and then our gradient is going to be the difference in the height over the difference in x. Our area is going to be that distance h multiplied by the width of our aquifer. So that's our area. And so this is important to remember that this height over here is just from the bottom of your confining layer to the top of the water table. And so we can solve for the flow by doing a little bit of differential calculus, differential equations here. So we're just going to start separating things out a little bit. So you've got your flow over here, and that's going to be divided by your constant, which is your permeability. In this case, the width is going to be constant, so we'll put that over there as well. So the width and the permeability are both constant. And then we'll bring your dx over here, and that's going to be equal to negative dh and h. And then we can just integrate those two. We'll integrate from x1 to x2. We'll integrate from h1 to h2. So this is just going to be equal to negative h2 squared divided by 2 minus h1 squared divided by 2. And this is just going to be equal to x2 minus x1. And then we'll multiply this by these constants. And then we could just rearrange things. And so then your x2 minus, solve for the flow. So your flow is just going to be equal to h1 squared minus h2 squared. And I just switch those. That negative here becomes a positive, and that becomes a negative. And then we'll divide this by x2 minus x1. And then we can multiply this by k, multiply it by the width, and then everything here is divided by 2. Okay, and this is the Dupuit equation. And so it's easy, relatively easy to solve. And so in the next example, what we're going to do is we are just going to do a simple solution to determine what the flow is.